remember that inverse operations undo each other or cancel things out. So logarithms are inverses of exponential functions. So logarithms and exponential things are inverses of each other. They should cancel each other out. Before we try a few of those, because these are actually going to be very easy problems, they're just weird to get used to. Let's go ahead and let me just show you something on the side here that is very easy, just to kind of remind you of what's going on. If I gave you this expression x plus 5 minus 5, you would know that, well, that's just going to cancel out to become x, because positive 5 and negative 5 are opposites. They just cancel each other out. That's what they do. We don't have to really think about why, just that's what happens. Similarly, if I gave you 5 times x and then divided that by 5, again, you would know those just cancel out, because multiplying by 5 and dividing by 5 are inverse operations. The same thing's going to be true once we start working with logarithms. It's just a brand new kind of operation that we're working with. So this first expression, I've got log base 5 of 5 to the x. Well, because log base 5 is being done to something with a base of 5, those are considered inverse operations, and log base 5 of 5 cancels out. All that leaves behind is just that x, no longer an exponent, just an x. Okay? It's weird, but that's all we're doing. It's think of it as adding 5 and subtracting 5. Log base 5 of 5 are inverses of each other. Another way we can work with this is if I have a base raised to a logarithm, that's another way to have an inverse operation. So in this case, I've got 10 raised to the log of 4. Now at first glance, it seems like that log doesn't have a base, but remember, there's always an invisible 10 there. Because those numbers match up, then I have a base of 10 raised to the log base 10. Those are going to be inverse operations and cancel each other out, so just that 4 is left over. Are you getting the hang of it? Don't think about it too much, just go with it. They're inverse operations, they're going to undo each other. Over here on the left, or on the right, sorry, I've got e raised to the natural log of 9. Remember, natural log is the same thing as log base e, so if I want to rewrite that, of 9. Once again, kind of like that last example we looked at with the tens, e raised to the log base e, since they have the same base, they are just going to cancel each other out and leave behind just that exponent. Okay? And then one more we'll take a look at before things get a little bit different. I have the natural log of e raised to the 3x. Well, remember, natural log is just the same thing as log base e. That's what natural log means. Of e to the 3x. Because those e's are the same, I have the same log base as the base of the exponent. Those are considered inverses, so they will cancel each other out. Again, don't think too much about this. This is one of the few times I say don't think about it. Just go with it. Log base e of e are inverse operations. Let's take a look at these last two examples where things aren't as easy as just crossing out the logs. So notice how these are different. This time I have log base 5 of 25. Now logs will only cancel out bases if they're the same base, and right now they're not. Compare it to doing something like x plus 5 and then minus 25. Even though we have opposite operations, the same number's not going to cancel out. So I can't just cross out like I did before. Instead, here's going to be the trick. Let's focus on just the 25. I want to think of a way to make that 25 a 5, so that I would have the same bases. Well, I can't just change it, like I can't do a square root to change it, but I could rewrite what the 25 looks like. For example, I know I want to make it a 5 because I want it to match up with the log base that I have. Well, what can I do to 5 to make a 25? Well, I could square it. And so just take a look at what I've done. I haven't changed the value of this. I just changed what the 25 looks like. 5 squared is the same thing as 25. If I go ahead and rewrite what's around it then, so I notice I've got an x in the exponent as well, and then in front of this I've got log base 5. Now I can see that I've made the same base. Log base 5 of 5 are inverse operations, and so all that's left is 2x this time. Okay? So there's a little bit of work I need to do to rewrite these, but that's it. There should always be a way to do this if the problem is going to be simplified. So let's take a look at one more. I've got log base 3 of 27 to the x. Well, log base 3 of 27 are not inverses, but if I look at just the 27, I can rewrite that as 3 to some power. I chose 3 because I wanted it to match up with the log base that I already have. So 3 to what power gives me 27? Well, a little bit of thinking should help me realize pretty quickly that that's just 3 to the third power. I haven't changed the 27, I just changed what it looks like. 3 to the third is the same thing as 27. So let me add the stuff that's around that back in the problem. There was an x in the exponent, and then in front I have log base 3. Because I'm doing log base 3 of 3, those are considered inverse operations, and all that's left is that 3x as my answer.